Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's the only way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Here is the first example on composite structures. So for the composite structure shown below, determine the maximum moment in the beam and the force in the rod. Disregard shear effects and axial effects in the beam. So let's make the redundant force as the tension force in BC as shown in the figure. So let's call that F. So this will be our sectioning. There will be two sections only. So partial of U with respect to F equals 0. Then it is equal to integral of negative 45 times x. Since this is not a function of the redundant force F, then its differential is 0. So divide by modulus of elasticity of wood, then moment of inertia of wood. Then in this segment, we have integral of fx minus 45 times 3 plus x. Then the differential is x dx, then over E of wood, I of wood. So these are the only equations that can be set up. No more elements. There's no axial force in the beam, though it is mentioned here we have to disregard axial effects as well as shear effects. Based on experience, the shear effect is very minimal. The contribution is very minimal, and we experienced that from previous problems on frames. So evaluating, by the way, we have force in the rod F times partial derivative of F is 1. The length is 3 divided by area times E for this rod here. So 0, this is the value of the integral here is 72F minus 5670 over E of wood, I of wood. Then of course this is 3F over AE. So to be consistent with the units, remember that you have to multiply this by 1000 to the 4th to convert the numerator to Newton mm cube, because the denominator is Newton mm square to make it mm, while the second term should be multiplied by 1000 square so that the numerator will be in kilonewton, will be in Newton mm, and the denominator is Newton, so it will make mm. So 72 F minus 5670 times 1000 to the 4th over E of wood is 10,000 megapascals. Then moment of inertia 720 times 10 to the 6, so that is in mm. 3F 1000 square over area of steel rod, pi 11 square, pi radius square, E is 200,000 megapascals equals 0. So computing, simplifying 10F minus 785, 87.5 plus 0.03946F equals 0. So finally we can solve F, 78.44 kilonewtons. So the stress in BC is F equals 78.44 kilonewtons tension. The moment at D is F, assuming positive, MD plus 45 times 9 equals F 78.44 times 6. So MD is 65.64 kilonewton meter, while the moment at B is negative 45 times 3. So since moment at B is greater in magnitude, the maximum moment in the beam therefore is 135 kilonewton meter, and it is negative. So that's it for this problem.